Hello everyone, I'll be covering Module 4, Engineering and Science. The first period we'll cover is the Progressive Era. Progressives tackled social problems such as growing power of corporations and corruption of urban politics. Notable Progressive Era accomplishments were the women's suffrage or 19th Amendment in 1920. Followed by World War I and the Roaring Twenties, we saw incredible growth in technology and the stock market continues to grow, but it unfortunately leads to economic issues, and in 1929 the stock market crashed, otherwise known as Black Tuesday. After this, we see World War II events, also leading to the Cold War after that. Corporations become much more common during this time. Corporations were considered upbuilders, which reshaped a lot of social context. We see New York City's Great White Way, or Broadway, Henry Ford in the Model T, and AT&T coming from Bell. Some of the advantages of corporations are the ability to raise money necessary for large technological projects, and also they're able to attract top engineering talent. Some of the disadvantages of corporations, they often promote concentration of wealth, and they focus on the needs of the customers rather than laborers. Most other professions such as lawyers, doctors, teachers, and clergymen are not as integrated with corporations as engineering. Progression from an engineer to a manager is also more common in engineering than almost any other profession. There's a lot of pull. In a sense, there's better pay, desire to move and improve organization performance, or also company loyalty. There's a push because there is a routinization of a lot of engineering work that we see by coming into this role. Engineers also contribute to management theory during this time, and they also coordinate with the corporate bureaucracy. For most engineers, the restrictions of corporations have not been that taxing because it's really a similar feel for their standard style of work. One example, we can see George Campbell and Michael Pupin. Pupin actually filed a patent for loading coils, and AT&T didn't defend George Campbell, but ended up purchasing Pupin's rights instead. Engineering work has a great impact on the workers that perform the tasks as well. Many times it is also degraded worker experience. Management hours in work versus sometimes a 10 to 14 hour workday with no benefits or safety regulations. There were also political reforms during this time. We see a lot of safety increases and also labor unions. One example is Frederick Winslow Taylor, who argued increasing productivity would raise wages. He observed the amount of time in each step to increase productivity, but ended up stripping authority and autonomy from the laborers. Another example is Ford's assembly line, which inevitably was an engineering marvel, but unfortunately de-skilled many laborers by increasing repetitive tasks.
Hello everyone, my name is Justin Blue and I'll be covering the first half of Module 5. First half of Module 5 covers an overview of history surrounding the Cold War era and engineers in the military before the Cold War. During this time, the Cold War era consisted of ideas of American democracy versus the Soviet Union's communism. After the Cold War, America did not demobilize after the war, which had resounding effects on America's engineers in the future by focusing on military technologies. This includes the focus of nuclear proliferation and battles taking place around the space race. This era's end was signified by the collapse of the Berlin Wall in 1991. The second portion of the first half of Module 5 covered the military influence on engineering before the Cold War. Dr. Clark does a great job of outlining 4 phases of military influence that leads up to this point in history. Phase 1 is the period of 1800 to 1860 with West Point, the Army Corps of Engineers, and interchangeable parts and gun manufacturing. Phase 2 has less military influence with land grants and industry playing a huge role. Phase 3 is the world wars considered industrial wars that involve government-sponsored engineering, and Phase 4 involves the constant military spending that we see throughout the Cold War.
Welcome to the second half of Module 5. In this module we will be discussing engineering and the ethics of engineering during the Cold War era. Now, a number of big projects happened during the Cold War era. Research and development funding from the government increases to billions of dollars per year by the 1960s. And this causes much larger teams to be formed and multiple organizations working together on projects. An example of this is SAGE. SAGE, although deemed largely a failure because of the extreme cost and the lack of output, did pave the way for big computing upgrades and eventually graphical user interface. This leads to the space race, which is between the US and the Soviet Union, and this eventually does create NASA for the US because of the Soviet Union being the first manned mission in space by Sputnik. and then thus causing the U.S. to create NASA and eventually land a man on the moon in 1969. And this leads to the ethical portion of engineering. As the military gathers funding from universities and other organizations, the question is it ethical for them to do so? An example of this is the physicians that worked on the nuclear bomb were never consulted about how it could be used or when it should be used, and it obviously was used for destructive purposes. But on the adverse side of that, the government has been responsible for significantly helping with aircraft safety upgrades and taking over aircraft control, resulting in many, many less deaths and safety-related issues in that. And this concludes Module 5, and now on to Module 6.
Module 6 is the politics of algorithm. An overview of that is going to cover algorithms, women and minorities in technology, and electronic waste. Starting with algorithms, one of the articles that we read was about Allegheny County in Pennsylvania. There was data points that were put into an algorithm to find children of abuse and predict those scores. Because of the information that was put in by the systems that they chose, it targeted poor families, and more of those children were taken away from those people. We watched TED Talk from Sophia Noble about the algorithms of oppression, pre-filling in Google not being monitored, and typically having racist or negative things to say about women and minorities. Algorithms also go into everything. I mean, our Facebook feeds, our searches on Google, Melvin's Kranzberg law, technology is neither good nor bad, nor is it neutral. Women and minorities in engineering, World War II sparked off women entering the technology field, but after the war, men came back and started to take over that field, and that leads into bro culture and what that's become today, which has continued to suppress women. Minorities have made gains in the field, but not in management. The last thing is e-waste. A lot of our waste is being shipped to third world countries where it's being harvested for precious metals. This emits toxic waste and tons of health problems for those nations. There's a lot of energy that's consumed by running technology, and that's something that we're going to have to address quite soon to save our planet and protect our resources that we have. That's all for Module 6.